In this video, we will talk about queues. Let's imagine that we have a pipe and we are inserting elements into the pipe. So let's say we have already inserted 4 elements. And what we want is to insert the elements that we have into the pipe from this direction. And whenever we retrieve an element, we only want the first element that got inserted to come out first. So the principle here would be FIFO, which is first in, first out. The element that gets in first will also get out first. So let's say we already have 4 elements inside our pipe. So this element got inserted first, then this element, then this element, and then this element. Now, the very first element, the one at the very beginning of the pipe, is called the head, and the very end of the pipe would be called the tail. Now, let's say we have this new element that we want to insert into our pipe. What would happen is that this new element would be inserted from the tail, and all of these elements would move forward. So if we want this kind of a structure where we can add elements and only retrieve the very first element that got inserted, we can use queues. Of course, this pipe is unlimited. You can insert as many elements as you want from the tail end. This is called first in, first out. Queues are usually collections that are designed to hold elements prior to processing. So if you remember our printer class that was in your homework, we implemented a queue for files. Whenever we needed to print a file, we inserted that file into a queue. And then we simulated the printer printing those files one by one in the order in which they were inserted into the queue. So queues are collections that are designed to hold elements prior to processing. Great. But queues are not necessarily always designed to be first in, first out. We typically use queues in this manner. We typically always use queues whenever we need a first in, first out order, but that's not necessarily what queues can only do. Queues can also be ordered in other ways. For example, a priority queue would assign a priority to each of these elements. So let's say the priority of this element is 1, which can mean that it has the lowest priority. It really depends on how the priority is set. Let's say this element has a priority of 2, and this element has a priority of 3, this element has a priority of 4, and this is the highest priority element with a priority of 5. Let's mark them so we actually understand which element is moving around in what way. So let's say these are our elements. If this was a priority queue, it would not matter what order they were inserted into the queue. The order of insertion would not matter. The order of the priority would matter. So in this case, if this was a priority queue, then these elements would be ordered differently. So let's reorder them in order of their priorities. So if this was a priority queue, this is how they would be ordered based on their priorities, and not necessarily based on the order in which they were inserted. So priority queues order elements based on priority. So the queue interface can be used in many different ways. It can be used as a FIFO queue, it can be used as a priority queue, and it can be used to have elements in any order that we require. However, mostly we use queues with FIFO ordering. Remember that whichever ordering we use, the element at the very beginning of the queue is the head, and the very end of the queue is the tail. Which element is the head and which element is the tail would depend on what kind of ordering we are using. If we use FIFO, then the first element that got inserted into the queue would be the head. If we are using priority queues, then whichever element has the highest priority would be the head. So you must know by now that queue implements the collection interface. So apart from having the basic collection operations that we saw in the collection video, and also the basic iterable operation, which is being able to use an enhanced for loop on each of these elements, apart from those basic operations, queue provides some additional operations for inserting elements, extracting elements, and inspecting elements. These are the methods that we can find in the queue interface. Let's look at the insertion operations. The two insertion operations are add and offer. So we can use the add method to insert a specified element E into the queue. Usually, whenever you use the add method, the new element is added to the tail of the queue. So this whole group of elements would move forward and the new element would be inserted at the tail. Now, when we are using unbounded queues, which means that the queues don't necessarily have a bounded capacity, then we usually use the add method. But when we have queues which have a specific capacity that we have set before, we usually use the offer method to insert elements into the queue. The only difference between the two is based on if the insertion operation fails, then what happens. If the insertion operation fails, then the add method throws an illegal state exception. We will learn more about exceptions in Chapter 7 when we look at exception handling. For now, just remember that add is used when we do not have a bound on the capacity of a queue and we are using a queue without having a specific capacity. But if we have a queue with a specific capacity, then we usually use offer as the insertion method of elements into the queue. So these two are the insertion methods that are provided in the queue interface. Let's now look at the extraction methods. Remove and poll are the two extraction methods. When we use remove, it retrieves the element at the head of the queue and removes it. So when we use remove, the element at the head is returned, but it is also removed from the queue. When we use the poll method, the element at the head is again removed and also returned. The only difference between the two is what happens if the queue is empty. If the queue is empty, then the poll method returns a null value. But if the queue is empty and we use the remove method, then we get an exception. Again, we'll learn about exceptions in the exception handling chapter. So not much difference between poll and remove and add and offer. Poll and remove are more or less the same, except when the queue is empty. And add and offer are also more or less the same to each other. And the only difference is how they react when we have queues with different capacities. Lastly, let's look at the inspection methods. We have two inspection methods, element and peak. Element retrieves the head of the queue. It returns the element at the head of the queue, but does not remove the element from the head of the queue. Peak does the same thing. It does not remove the head of the queue, but returns the element that is at the head of the queue. Again, the only difference between the two is how they act when the queue is empty. If the queue is empty, then peak returns null. And if we use the element method on an empty queue, then this returns an exception. So these are the different methods in the queue interface. What you would notice is that all these elements handle the head of the queue. Either they remove the head of the queue or they return the head of the queue. Nothing happens at the tail of the queue. The only thing that happens here is that when we add an element, it's inserted usually at the tail. And that only happens if we are using a FIFO order, which is first in, first out. If we are not using a FIFO order, then elements can be inserted anywhere based on their priority. However, whenever we are working with the queue, all these methods usually only deal with the head of the queue. The head element is the only thing that gets retrieved or removed. If we want to access both the tail and the head of the queue, that is when we use a deck. A deck is a double-ended queue. So we can access the elements on both ends. The methods that deck has are exactly the same as that of queue, except that those methods are applicable for both ends of the queue. So you see, we had the add method for insertion and the offer method for insertion. But here we have the add first and offer first methods, as well as the add last and offer last methods. They do the same thing, just in opposite ends of the queue. It's the same for the remove methods. We have remove first and poll first, and we also have remove last and poll last. The same is true for examining or inspection methods. We have the get first or peek first methods, and we have the get last or peek last methods. We can also use the deck implementation like a stack where the order is last in, first out. If you compare the different methods that deck has compared to the methods that stack has, you will see that the push method in stack is exactly equivalent to the add first method in the deck implementation. The pop method is exactly similar to remove first method in the deck implementation. And the peek method in the stack class is equal to the get first method in the deck interface. So instead of a stack, if we want to use a deck to create a structure where we are following the last in, first out order, we can just use these three methods to create a structure that is exactly like a stack. And that is more desirable because stack is more of a legacy class. And modern programs usually use the deck implementation to create a last in, first out data structure. Now, queues can have duplicates if we are using the first in, first out ordering. But if we are using a priority queue, if we have duplicates, then we have to make sure that the duplicates have differing priorities. You can use null values as elements and insert them in a queue, but it is strongly recommended that you do not use nulls as elements whenever you are using queues. This is because a lot of the methods that we've seen here return null to show that a queue is empty. So if you have null as elements themselves, then that would create a conflict. So usually we never use nulls as elements whenever we are using queues. Since we are only going through basics, we did not go through priority queues in too much detail, but I hope you understand what priority queues are. And so this video not only discussed queues, but also decks. Next, we are going to look at linked list.